Hello everyone and welcome back. So today we're going to be going over Statics and Strength of Materials Chapter 2, which is on the principles of statics. The principles of statics. So let's get right to it and begin. So before we get to statics, we need to talk about Newton, Sir Isaac Newton, and his laws. So his first law was every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. The second law, force is equal to the change momentum per change in time. For a constant mass, force equals mass times acceleration. And the third law, for every action, there is an equal and opposite reaction. And I've always loved this picture. Don't always cause an action, but when I do, it provokes a reaction. Okay, now this is all we're going to talk about in this little mini lecture. Most of these have equations that are connected to it. For this one right here, it's force equals mass times acceleration. Okay? And this one right here is saying that if we want to change this, we're going to have to apply a force to it. So it comes down to this one as well. So both of these are connected here. This one right here says for every action, there's an equal and opposite reaction. And that makes a lot of sense. If we set a box on the ground, it has some sort of weight, W. And if there is no force pressing up on it, well, then obviously that box is going to fall through the ground. Now that doesn't happen, hopefully. And so what it tells us that there is an equal force pressing back up on the box. And we usually call that N for a normal force. Okay, so first law. An object in motion stays in motion, an object at rest stays at rest. That's how it's normally said when we're not using such fancy language. And what I like to say is this is the reason it's so hard to get up in the morning, because you're an object to rest and you don't want to get out of bed. And so hard to go to bed at night because you're an object of motion and you don't want to stop. And the only way to stop something is by applying forces. Okay, applying forces. Now, in this class, at least for quite a while, things don't start moving when we're working with them, okay? They might bend. You go to this, or they'll stay the same. We might say that they're rigid, and so that we apply that force, and it is going to resist that with some internal force. So we will have no acceleration. That's always going to be equal to 0. So in this class, what that's going to tell us is that if we have any forces, if we add them all together, they're going to equal 0. All the forces are going to sum to 0 in this course. Okay, so that's pretty much it for here. We see a couple different things. One, when we add up all the forces acting on our objects, it's going to equal 0. 2, for every action, there's an equal and opposite reaction. So if you're drawing a free body diagram, which you'll learn how to do in this course, there should be arrows blocking it from every direction. So if there's an arrow going to the right, we need an arrow to the left. If there's an arrow going down, we need an arrow that's pointing somewhat upward. Otherwise, it can't actually stay in equilibrium and it will begin to move. And that doesn't happen in statics. Because in statics, things stay static. It means stationary. It doesn't go anywhere. Now, I've been drawing these little arrows here, and those are all marking different forces. And so next time we're going to be talking about what are forces, how do we work with them, and some laws that govern them. So, thanks for listening, and I'll see you all next time.